In this video, we will learn what sets are, how they differ from lists, and how to use some of the common methods that sets provide. We will also discuss the advantages and disadvantages of sets, and when to use them in your Python programs. So, what are sets? Sets are an unordered collection of unique items. This means that sets do not have a fixed order or index, and they do not allow duplicate elements. You can create a set by using curly braces and separating the element by comma, or by using the set constructor on an iterable object such as a list or a string. For example, let's create a set of fruits. Fruits equal open curly brace, apple, comma, banana, comma, orange, comma, mango, close curly brace. We can print the set to see its content. Notice that the order of the element is not the same as when we entered them. This is because sets are unordered, and Python does not guarantee any particular order for them. You can add an element to a set using the add method. For example, fruits.add_apricots. Also notice that there are no duplicate elements in the set. If we try to add an element that already exists in the set, it will be ignored. For example, let's try to add another apple to the set. Once done, if we print the fruit, the output will be the same as before. This is because the set only stores unique items, and they do not allow duplicates. There are several ways to remove elements from a set, using the remove method for example. If the element you are trying to remove is not in the set, like peach, the remove method will raise a key error. To avoid this, you can use the discard method instead. This method will not raise an error if the element is not in the set. You can also use the pop method to remove an element from the set. This method removes and returns an arbitrary element from the set. But be careful, since sets are unordered, you won't know which element will be removed. To check if an element exists in a set, you can use the in operator, like as banana equal banana in fruit. You can traverse a set in Python using a for loop. Be careful, since sets are unordered, the order in which the elements are traversed is not guaranteed. Here is an example. Let's assume we've got the set fruits equal apple, banana, orange, and mango. And we use a for loop for element in fruit, print element. The code will print the element of the set fruit, but the order in which they are printed is not guaranteed. The unordered nature of set is a common source of misconception among novice programmers. Often, I can hear my students asking, how can I get the first element in a set? The answer is simply, you cannot, as there is no notion of first, second, and third element in a set. The element is in the set, or it is not. That's all. Let's look at some examples of typical use cases for sets. One common use case for set is to remove duplicates from a list or a string. For example, if we have a list of names that contains some repetition, we can convert it to a set to get only the distinct names. Similarly, if we have a string that contains some repeated characters, we can convert it to a set to get the unique characters. We can easily remove the duplicate from the list name list by converting the list into a set and then converting it back into a list. But be careful. Notice that the order of the element has changed because sets are unordered. We can also use sets to perform mathematical operations on collection of items, such as union, intersection, difference, and symmetric difference. This operation returns a new set that contains the result of combining or comparing two sets. For example, we can use the union method to get a set that contains all the elements from two sets. Given the set colors1 and colors2, the set all colors equal colors1.union colors2 contains all the colors from the two sets. Alternatively, we could have used the vertical bar operator as a shorthand for union. Another common use case for set is to check if two collections have any elements in common. For example, we can use the intersection method of sets to find out the common colors of two sets. Alternatively, we can use the isDisjoint method of sets to check if two collections of colors have no element in common. We could also use the ampersand operator as a shorthand for intersection. A third common use case for set is to find the difference between two collections. For example, we can use the difference method to get a set that contains elements from one set that are not in another set. We can also use the minus operator as a shorthand for difference. We can use the symmetric difference method to get a set that contains the elements from both sets that are not in common. In Python, both lists and sets are used to store collection of items. However, there are some key differences between the two that can help you decide when to use one over the other. Order. Lists are ordered, meaning that the items in a list have a specific order that is maintained. Sets, on the other hand, are unordered, meaning that the order of items is not guaranteed. Uniqueness. Sets do not allow duplicate items, while lists do. If you need to ensure that all items in your collection are unique, a set might be a better choice. Mutability. Lists are mutable, meaning that you can change their content, adding or removing items, for example. Sets are also mutable, but their element must be immutable. That is, you cannot have a set of lists. Membership testing. Checking if an item is in a set is faster than checking if it is in a list. This is because lists have to scan through all their elements one by one until they find a match or reach the end of the list. Sets, on the other hand, use a technique called hashing, which allows them to quickly locate an item without scanning through all their elements. Hashing works by assigning a Unicode, or hash, to each item in the set, and then storing them in a table based on their hash value. This way, sets can directly access an item by using its hash value without having to compare it with other items. For example, let's compare how fast lists and sets can check if an item exists in them or not. We will use a large list and a large set with 10 million elements each. And we will use the time module to measure how long it takes to perform this operation. As you can see, checking the set was much faster than checking the list, because sets use hashing to quickly locate items. Sets consume more memory than lists. For example, let's compare how much memory lists and sets use. We will use the sys module to measure the size of each object in bytes. As you can see, the set uses more memory than the list, even though they have the same number of elements. The reason behind the extra memory is beyond the scope of this video, but the interested viewer should look at hash table to know more. So, when should I use a set and when should I use a list? The answer depends on your need and preferences. Generally speaking, you should use sets when you need to store unique items, when you need to perform fast membership tests, or when you need to perform mathematical operations such as union, intersection, difference, or symmetric difference, and when the order of the element does not matter. You should use lists when you need to store ordered or indexed data, when you need to preserve duplicates, or when you need to access or modify elements by their position. Sets are powerful and versatile data types that can help us perform various operations on collection of elements. To learn more about sets and how to use them in Python, you should check out Python's documentation. Thank you for watching and see you in the next video.